In 2003, a vision began to take shape on the Olympic green in Beijing. The goal was to build the world's largest steel structure, a stadium that looked like a bird's nest.
Designed by Herzog and de Meuron, this wasn't just a stadium. It was a massive puzzle of interlocking steel.
But before the steel could rise, the earth had to be moved. Construction officially began in December 2003.
Hundreds of machines worked day and night to excavate the foundation for an 80,000-seat venue.
The precision required was absolute. This foundation had to support 42,000 tons of steel.
They dug down deep, preparing to anchor this massive beast against earthquakes.
Thousands of reinforced concrete piles were driven into the soil to stabilize the loose earth.
A mesh of steel rebar was laid down, creating the skeleton for the concrete base.
Then came the pour. Thousands of gallons of concrete flowed to create the basement level. Chinese laborers worked in shifts, ensuring the concrete cured perfectly without cracks.
This base would separate the stadium's two distinct parts, the concrete bowl inside and the steel nest outside.
With the foundation set, the team prepared for the next phase, the inner seating bowl.
Unlike standard stadiums, the bird's nest is actually two structures completely separated from each other.
The stage was set. Now, the factory work began.
All right, bring it up steady. Clear on the left. Watch the alignment. Lower it slowly, we have the mark.
This inner structure carries the seating tiers and the roof over the stands.
It was a standard reinforced concrete job, but the scale was immense.
Every pillar had to be perfectly aligned. Even a millimeter off could ruin the symmetry.
As the months passed, the bowl grew taller, creating the amphitheater shape.
These risers would eventually hold 91,000 spectators during the Olympics.
Quality control was rigorous. The concrete had to withstand decades of weathering.
By 2005, the concrete heart of the stadium was largely complete.
But the true challenge, the iconic steel nest, was still being forged in factories far away.
The concrete stood alone, waiting for its metal armor.
Engineers left a gap between the bowl and the future steel shell to allow them to move independently during an earthquake.
The site was cleared. The cranes were repositioned.
Before the steel could be installed, a forest of temporary support towers had to be built.
These temporary legs would hold the weight of the steel until the entire nest was connected.
The site was ready. It was time for the steel. The bird's nest required a new kind of steel. Standard steel would be too heavy.
Engineers developed Q460 steel, high strength, but incredibly difficult to weld. This steel was produced specifically for this project in Chinese factories.
The design had no straight lines. Every beam had to be twisted and curved.
Giant hydraulic presses bent the steel into the complex organic shapes required by the architects.
Precision was key. These pieces had to fit together like a 42,000-ton 3D puzzle. The beams were not solid. They were hollow box sections, welded together from plates.
Some components weighed as much as 350 tons.
If the curve was off by even a fraction, the loop wouldn't close on sight.
This was the most complex steel fabrication job in history at the time.
Once fabricated, the steel was prepped for the long journey to Beijing. The logistics were a nightmare. Massive convoys transported the skeleton piece by piece.
They moved at night to avoid traffic, carrying the DNA of the bird's nest. Back in Beijing, the site had become a marshalling yard for thousands of steel members.
Each piece was numbered and assigned a specific coordinate in the nest. The assembly was about to begin. Organization was critical. One wrong piece could delay the entire project.
These were the ribs of the beast.
Safety checks were performed. The lifts would be heavy and dangerous. The erection of the steel structure was the most dangerous phase of construction.
It started with 24 main truss columns. These are the primary load bearers.
These columns were spaced around the perimeter, anchoring the nest to the earth. The fit had to be exact. Workers used brute force and precision to align the giants.
Each column stood on the temporary support towers built earlier.
Slowly, the outer perimeter was defined.
Next came the connecting trusses, linking the columns together. Welders worked at dizzying heights, battling the wind.
The welding of Q460 steel required specific temperatures.
In the freezing Beijing winter, they had to preheat the steel so the welds wouldn't crack.
Work continued 24 hours a day. The stadium sparked like a fireworks show at night. They maintained the steel at a steady temperature to ensure the molecular bond held.
The structure cantilevered over the seating bowl, seemingly defying gravity.
The roof opening is saddle-shaped, requiring complex curved beams.
As more steel was added, the nest pattern began to emerge. These were the ribs of the beast.
These brave workers navigated the tangled web with incredible skill. Communication was vital between the ground and the air.
By 2006, the primary skeleton was finished, but it was still resting on crutches.
The temporary supports were still holding the weight of the roof. Before they could remove the supports, they had to weld the secondary members.
The secondary beams created the chaotic, random look of twigs in a bird's nest.
But Ariel and Pashley. While they looked random, every placement was calculated for structural integrity.
The aesthetics mattered. The steel had to look continuous and organic.
Catching. 42,000 tons of steel were now floating above the concrete bowl.
Some nodes connected up to 6 different beams in different directions.
Every weld was X-rayed and tested for internal flaws.
September 2006, the most critical moment had arrived. The unloading.
78 huge hydraulic jacks were placed under the structure.
The plan was to lower the jacks, removing the temporary supports, letting the stadium stand on its own.
If the calculations were wrong, the roof could collapse.
Slowly, millimeter by millimeter, the jacks were lowered. The massive steel roof began to settle under its own weight.
The structure groaned as it took the load, settling into its final shape.
It settled by exactly 27 centimeters, just as the computers predicted.
The bird's nest was now standing on its own feet.
A major engineering milestone had been achieved.
Now, the forest of support towers could be removed.
The interior of the stadium was finally revealed.
The complex geometry of the roof was now visible against the sky.
But it wasn't waterproof yet. It was just a skeleton.
The next phase was to wrap the nest in a high-tech skin.
To cover the roof, they didn't use glass. They used ETFE cushions.
This material is light, strong, and allows sunlight to filter through. It works like a balloon. Air is pumped into the cushions to keep them inflated.
This gives the stadium its bubbly, textured look from the outside.
It protects the spectators from rain while letting in light for the grass.
A second acoustic layer was added underneath to absorb sound.
The system also harvests rainwater, channeling it into underground tanks.
Inside, thousands of workers began installing the 80,000 red seats.
Distance boards the underruffles. The color red was chosen to symbolize luck and joy in Chinese culture.
The stadium was coming to life.
The field itself was a complex system of drainage and heating.
Lighting systems were integrated into the steel structure to avoid glare. Modern technology fused with the ancient pottery-inspired design. The steel received a final coating to protect it from corrosion and pollution.
Every detail was refined as the 2008 deadline approached.
The bird's nest was no longer a construction site. It was an arena. The acoustics were tuned to amplify the roar of the crowd.
Solar panels were connected to power the stadium's lights.
Cleaning crews prepared the venue for its grand opening.
After nearly 5 years of labor, the job was done.
Completed in June 2008, the National Stadium stood as a symbol of a new China.
The random steel twigs formed a unified, incredibly strong structure.
It cost $423 million and used 42,000 tons of steel.
It hosted the spectacular 2008 Olympic opening ceremony.
And in 2022, it made history again as the first stadium to host both Summer and Winter Olympics.
Today, it remains a global icon of architecture and engineering.
Maintained carefully, it continues to serve as a cultural center.
From a hole in the ground to a masterpiece of steel.
The bird's nest proves that with engineering and determination, anything can be built.
This is the power of construction.